Okay, so lesson 13 for anyone who missed class on Wednesday, this is what we did. We just need to do the multiplying complex numbers. So one of the things we need to remember, any time you have I, we leave I in the answer, but any power of I, we need to simplify. If you see I squared, you need to replace it with -1. If you have I to the third, you need to replace it with -I. And if you have I to the fourth, it equals a +1. All right, so having said that, when we multiply 4i times 3i, we multiply our coefficients. 4 times 3 is 12. When we multiply I times I, we get I squared. So this is 12 times I squared, but remember, I squared is -1, so I can substitute -1. Then 12 times -1 is -12. In this one, we have 4 times -3, so that's -12. I times I is I squared. So I have -12 times -1, which is a +12. When I multiply here, -2 times -5, is 10. I times I squared. So we have 10 times -1, which is -10. And here, thinking outside of the box here. -5 times 5 is -25. I squared. So -25 times I squared. So notice every time, because we're multiplying by -1, we're just changing the sign of the coefficient every single time. All right, now you can't see this down here, but it's -5i squared, because if you look, we're just on the 13.1 out of your binders. -5i, I would recommend when you see the square to rewrite it, because then you're going to see exactly what you need to do here. So -5 times -5 is 25. I times I squared, but I squared just changes it, makes it a -25 because I squared is -1. All right, now we're going to move on to 13.2. 13.2 is just a matching. So if you'd want to pause the video and work your way through, I would simplify this side, simplify the left side so you can match it to the right. 5 times 7i. See, this one just has a single I, so we are left with 35i. We never replace I because I is just I. We just leave that. So this square matches with this square. But 5i times 7i, make sure you account for your i's. This one just had a single I. This one has I times I, which is I squared. But I squared just makes that a -35. This is 3i squared, so that just makes it -3. 3i quantity squared means 3i times 3i, which is 9i squared. So that turns into -9. All right, I to the third, if you recall, is -I. So I replace I to the third with -I. 8 times -I is -8i. I to the fourth is just +1. If you just look back at your notes, we have all the powers of I written. Be careful on this next one. This is the opposite of I squared. The opposite of I squared is a +1. So both of these squares match to 1. Then this is -I times negative I, but a negative times a negative is positive I squared, but I squared is -1. Now, the main part of the lesson is 13.3. The good news is it's not super difficult if you're good at distributing. So we just have a single 5i at the end that we should distribute back. 5i times -3 is -15i. 5i times 9i is 45i squared. Now, when I'm rewriting these, sometimes what I'll do, I'll change my color. I squared just will make that 45 a -45. So sometimes I'll just do it that way to save me a little time and effort. But that means that I squared is totally gone. This just turned into a real number. Now, notice in the form a+bi, they want the real number first. Your answer should always end in I. So I'm going to put the -45 first, then -15i. I'm just changing the place so this matches a+bi. In number 2, we're going to multiply, distribute out the 8. 8 times -5 is -40. 8 times 3i is 24i. Then distribute the I times -5, -5i. I times 3i is 3i squared. Every time you distribute complex numbers, you will always have a real number first, then 2 imaginary numbers, then you should always end with I squared. But what does I squared do? I squared makes it a -3. So if this is just a -3 here, I can then combine it with my other real number of -40 to get -43. You should always be able to combine the first and the last, and then the middles are the imaginary portion. 24 minus 5, 19i. And this is in the format a+bi. I want you to be very careful about number 3. When you square a quantity, you should always write it out. We're taking 3 plus 2i times 3 plus 2i. When you write it out, you can see that you need to distribute. Don't make any silly mistakes. So 3 times 3 is 9. 3 times 2i plus 6i. Then distribute the 2i. 2i times 3 is 6i. 2i times 2i is 4i squared. So notice once again, we have the real number first. The I squared makes this a -4 that I can combine with the 9. 9 minus 4 is 5. Then I can combine my imaginaries. 6i plus 6i is 12i. And this is in the correct format. Now, number 4 actually has a special term. We call these conjugates. Conjugates you can recognize where everything is the same except one is a plus, one is a minus. So let's notice what happens when we multiply conjugates. 3 times 3 is 9. 3 times -2i, -6i. Then distribute 2i. 2i times 3 is 6i. 2i times -2i, -4i squared. So the I squared makes this a +4, so I can combine 9 plus 4 is 13. These are called conjugates because my imaginary terms cancel. I am left with just a real number because my imaginaries cancel out. Now, if I want to be technical with my a+bi, technically it'd be 13 plus 0i. So that would be my final answer. When you multiply conjugates, though, The middle terms cancel and you're just left with a real number. Now what I'd like you to do, if you turn in your binder to, I think it's number 6 in the practice problems for 13. There's a graph. Oops, hang on a second. In 13 practice, number 6 is practice graphing. Make sure that you're comfortable graphing complex numbers. That will be on the checkpoint. And when you get done with the graph part of 13, turn to the 14, lesson 14 practice. Oops, hang on. The lesson 14 practice, this will give you some good practice for the checkpoint. All right, so on the checkpoint, make sure you know how to graph, how to add, subtract, and multiply complex numbers. That's going to be the main part of the checkpoint.